One, oh, one is one. Yes. And then you see that with these. Yes, that's more than. It's on my desk. That we want on the morning, we're gonna go and rewind. Yeah, but you have to write down. On more than one of the. Oh, yeah.
In there, you can see on the floor.
It's greater than one. Something involved, yeah, great. And then one witness. More than one. So do you just very calculated by the
Not myself. I don't go and walk about. It's one of these.
Oh, that's my.
I hate these. Try this one.
It's it's kind of egg. And then egg. One thousand. Oh, there it is. So, and it. No. Oh, my God. It's great.
So this binomial number 1.15. They binomial. Yeah. This properties are going to change. The birthday will compare from 1 year to the next. Okay. Actually, do better than this in the. So P is equal to 1/7, and you're looking at 7 years. Do you agree with that of these statement guys? But it's saying plus the times, what's all of that equal to? 1. Yeah, so it's going to be 1 minus 6/7, yeah, I'm right. First, yep. And so you should have got what, right?
260.
Right, well done. Okay, was it 0.2635? Are we happy? Hmm. Just a notation, by the way. If they say this, which they're allowed, what does this mean? Yeah, it's good. But the B means it's binomial distributed. N is 7, P is 1/7. Okay, so they can use that notation to give you information. But be careful of that. And remember, what does this mean? What does that mean? The data is normally distributed with a mu, and this is sigma squared. So sigma would be 12. Right? Okay, just make sure you're comfortable with that notation. Right, time.
Let's just do the 140.
We've got a time now. We've got a time from you. What should we do? 17 or 18 minutes? 17 minutes. That one gets you through whatever it is.
Children scared of something. My dad loves it. Just drove so bad. I don't think many places you know you can anyway. Trying to get.
Okay, everyone okay with that one? Right. Thanks, man. Right, so for 1.3, but the same scenario. But now we want to figure out. Okay, not quite the same scenario. Much of the B. Sorry, 1.1b. Okay. But now what's changed? Okay, X is now equal to the number of Sundays, birthdays on Sunday, how many years? No, N is what, guys? In 60 years. Okay. Right, so it's still binomial. The probability on 1 year. Okay, so X is the number of birthdays on a Sunday in 60 years. Okay. P is 1/7, but now N is equal to 60. Do you agree? Okay. And what do we want to know? What's the question say? Use a system approximation that your birthday will be on Sunday in at least 13 of the year. So we're looking for the probability that X is the bigger than, does the bigger than matter for this one? Yes, it does, because it's a normal approximation binomial, that's the only time in normal distribution that it matters, right? So what are we looking for? X is bigger than equal to 13. Okay. So you could go, if you're going to get the binomial, you're going to have to work out 13, 14, and up to 60, or even the other way around. 1 minus 12, 11 will still take too long. Okay. So that'll take too long to use the binomial. Okay, so we're going to use a normal approximation to binomials. Well, yes. Okay, so this is in the binomial notation, right? I haven't changed it to normal distribution. So the binomial, that's what we have to work out. Do you agree? Everyone happy with that? Okay. The approximation, the only approximation we use is a normal approximation to the binomial. So first of all, what do we have to do? It says justify your answer. So go justify, can you use a normal approximation to a binomial? Remember, that's got to do with skewness.
So you did the question of variance. Well, you did. Okay, let's go time. More one. Hold on. No. Logic way, why did I take 0 Nov? That can be only kills my own. So it has some fun without that. Oh. Take away. Yeah.
Right, so there's your justification, guys. Remember, you've got to remember those formulas on the formula sheet. Okay, NP, okay, has to be bigger than 5, it is. And N1 minus P has to be bigger than 5, it is. Okay, so you can use, okay, therefore, when you use,
Do you have to say therefore can?
no, or maybe just say, something like that. What's your next thing? Okay, you need to find, you need to find mu, use your formula sheet to help you, and you need to find the standard deviation. So now you're going to move into the normal distribution, and then you have to do your correction, right? Okay, so those 3 things come first. These 2, it's a fundamental part of the question. So now we move from bi to normal. Okay. On your formula sheet, remember you've got that E of X. E of X is the expected value, but that's in a binomial distribution. So mu is going to be NP. I would keep that mu to 5 decimal places. Okay. I'll probably keep it to 4 decimal places. What did you get? Low, final one. But what did you get? 8,57?
714.
714.
Yeah.
5714 or 57714?
571. Oh, okay. That's what I thought.
I believe it.
Okay.
Okay. 5714.
But then that was the area.
If you look at your, how does the formula sheet help you to get the sigma? Remember, you've got the tells you the variance, right? So sigma is going to be equal to the square root of NP1 minus P. Hang on. What did you?
6 root 10 over 7.
6 root 10 over 7. Okay. I would probably leave sigma like that. Yeah, I would round it off. If you get a third, keep the third. The final answer you should get is 0.0735.
Don't do things. So if you say 0.0735, you realize that.
0.0735.
And so, in terms of like, would you write your final answer as probability of x is greater than or equal to 13, or probability of x is greater than or equal to 12 and plus.
Doesn't matter. Nothing else to do with it. Okay. But you must mention that this becomes. So guys, if you want x to be bigger than or equal to 13, right? Think of 13 as a bar. Okay. Do you want to include the whole of the bar or not? Okay. You want the whole of the bar, right? So you're going to go from where? 12.5. Well done.
So let's say at most, which
At
is
most,
say
then you wouldn't include.
13.5.
That would include the 13 bar. Okay. So we're looking for the probability of x is from the normal distribution. This is what we want.
Yeah.
That's just for the binomials, but when we move into normal space, that's what we're going to do. 0.0735. So you didn't find the Z score that goes with this.
So you have to put back the P there, not.
No, I don't really like that notation that much. Okay. So you can say. Up total minus no. Okay, so Z is equal to x minus mu over sigma, and Z is going to be equal to 12.5 minus mu.
Projected even in percent.
No, okay. So Z is equal to what? Should have got a Z score of 1.45, right? Okay. So then.
So you ready? Let me search most common. Oh, I think it's not just one. They can be. You ready? You're thinking it has to be one. Plus, you choose 3 books in total. Oh, no, I'm choosing the other ones. You have to. We have 3 of them. One. Thanks, no problem. But it's just that it's no, without yeah, I'm being in front of 0. But I think most common. It's critically overall. It's 0 and not, but I try to.
Okay, so that area over here was 0.4265. That goes with the Z score of 1.45. So the probability x is bigger than 13 will be 0.5. Chop out that, and you get 0.0. Everyone happy with that one? Okay. Final answer 0.0735.
Oh, it's this way. two aggregates maybe result. Not the two. Oh, sorry. So these are variance, because you only have five, you can square that. I think the primary is like, of the case. What do you mean? I mean, oh, it's not. That's first part, that's all the two. One. Don't you? Yeah, I just found out what makes it. No, I just said that the area between the means and what's out there, How do you know? How did you get? Because you're not working in every house, but you're just trying to get working the boundary and it's this was a yeah. So each hotel is 25%. You know, you're saying like, after hotel minus no hotel. I'm sure it's like, feel and people that event, they not the same values, you're so great. Yeah, but there's maybe working in hotel. No, I know that the one. So the mean is based on the median. Yeah, so mean is. So then you find that.
Right, just pick. How long you trying? Okay, guys, just take 1.2. 1 second, guys. Okay, check the answer for 1.2, please. So you got 5 novels, 2 books. Okay, choosing 2 books to go away with. Okay, the probability of 2 novels. You're going to get 2 novels from 5. You're going to choose 1 biography from 2 to 7. You should have got an answer for 1.2 or 4 to 7. Each you should get 1/3. 15 over 7. And variance.
Oh, so you don't have to fill in the front one, so because probably will just be 0. Then you can go else.
No. Why would they contribute?
Yeah, one by one.
Yeah. Okay, so for that point, I'm very.
You might get no novels.
No, you can't.
Because they're 3, yeah. Okay, what's he choosing? 3, eh?
No, that's why the table was so like.
Confusing, yeah. Okay. So the probability of getting, well, you can put 0 in if you want to. Okay. He's choosing 3 books, right? Okay. So the probability, if he's choosing 3 books, but they are only, he's got 5 novels and 2 biographies, and X is the number of novels. Okay, well, you can't get in 0. That's 0, right? Okay. 1 would work out 2. 2 was equal to what? You worked that out already.
4 out of 7, 1 is 1 out of
2 was 4 out of 7.
3 is 2 out of 7.
Okay.
And it's also in the vote.
Okay, so you can have these combinations to get 1 and 3 as well, right? Yes. So,
Such a long.
so 1 novel will be 5, choose
Yeah.
1.
1 over 2, choose 2, right?
Yeah.
Which gives you that, right, so 1 novel gives you 1 out of 7. We're happy with that? Okay, to get 1 novel, you're choosing 1 from the 5 novels. You've got to choose 2 of the biographies from 2 over choosing 3 from 7 overall, so you get 1 over 7 for that. That's 4 over 7. Just use the negatives. I wouldn't work out the next one. You got to balance yourself. That's 1 over 7, that's 4 over 7, which is 5 over 7. So this must be 2 over 7, Judy. Okay, but you should get the same ones if you use combination. Everyone okay with that table? Okay, now go to your formula sheet right at the bottom of the page. Okay, if your formula for expected value and variable. The last 2 formulas you get. To calculate the variance, you first need to find the expected t.
It says me.
Did you go to check it?
Yeah. Yeah. But if your value.
X comma 0025. X comma 917. Oh, okay, they're not 3 decimal points. It's on stupid. I'm just thinking like that. Really, I just put weird jiggly that. And the ring is nice and stuff.
That's an 8.
Or you do gals. Maybe hours. I felt like I didn't know. No, people were sleeping.
So how do you work out e of x squared? You square the x value basically. Two squared is 4. Did I now work out e of x squared as an answer?
5.
What did you get? 5. Exactly 5.
So I got the different values increased and I thought,
Did you guys get e of x equal to 15/7?
Yeah.
So you should get 5 minus 15/7 squared,
this is 20/40.
which is 20/49. You write that decimal if you 0.408. You see what you're gonna say?
Oh, no, it's me.
Sure. Right, so just all of you check, see that you got 0.408 as your answer. You should have got e of x is equal to 50. So there's your formula for variance. So, hang on, but that's your variance. We've got to find the square root of that. What's the question? Find variance. Oh no, it says standard deviation, so that's fine. Okay, just to find the variance. So there's your formula for variance, right? E of x is 15/7. E of x squared means take your probabilities. Okay, so 1/7 times 1 squared. Okay, 4/7 times 2 squared. Okay, 2/7 times this is 3 squared over here. Okay, that's 2 squared. Okay, so e of x squared gives you 5. So then your variance is e of x squared, which is equal to 5 minus e of x squared, okay, minus e of x all squared, and e of x was 15/7. Okay, so 15/7 squared. You're wrong then. E of x squared, means take your x, this is x1 squared, this is 2 squared, this is 3
Yes,
squared.
yes.
If you get e of x squared is 5, you get e of x is 15/7. E of x is 1 times 1/7 plus 2 times 4/7 times plus 3 times 2/7,
And then you square that.
which is which is 15/7. Yeah, so your variance is going to be e of x squared, and e of x squared was equal to 5, right? Minus e of x, which was 15/7. But you got it square E of X. That's going to be 5 minus 15 over 7 all squared.
Square,
The E of X squared
yes.
means square the individual, so you're going to go 1 squared times 1 over 7. 2 squared times 4 over 7. 3 squared. That's what E of X squared means. That's what that means over there. Okay. With me? So that's what E of X squared is. Okay. But this means E of X all squared. Okay. You're going to find the upper quartile and the lower quartile. So the area in between is going to be what?
The area between the upper
Yeah. The area between them is a half, guys. The area between your upper quartile, if you have a normal distribution, okay, and you're looking at, okay, Q2 is over here, right? Q1 is over there. Q3 is over there. Okay, 25% of your data lies here. 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 So the probability of something lying between Q1 and Q3 is 50%.
So is that the answer?
No, that's just a strategy. Okay,
So we gotta find the X.
let's have a look at the questions. Okay. Did everyone, okay, let me just go into this question. Okay. So you got to find your Z score that goes with Q1. You're gonna have to find this Z score over here, guys. What's your Z score that goes with Q1? You can work that out. What is Z1? You can find that Z3 as well by using your table. And once you've got the Z1 and Z3, then you can go find the X values that go, you can find Q1 and Q3. Yeah, in the table, you're looking at 0.35. Are A and B related? You all manage A, you have to go over A. And you're not done 2.1. For 2.1A, you should get, okay, 0.7486. Did everyone get that?
Yeah.
Doesn't matter. Probably got to do a skills base. Okay. So just check you got, I don't have to go over 2.1A, yeah? You should get 0.7486. The slight variation probably doesn't get. Okay. If you looked up on the table. Then I got a Z score of 0.67. And a Z score of 0.67 gives me an area of 0.2486. There shouldn't actually be an error. Your Z score, you always round up to 2 decimal digits. You don't need to go over A? Okay. Right, but I'll just do B. Just be careful of your units, eh? So mu is 7.5. What did your standard deviation? Was how many minutes? 45. So 45 over 60.
So
Bit of fraction, which is 3 over 4, eh? Or 0.75 is fine. Okay.
that's. But in this case, the mean is going to manage to have fun. Yes. But just in that, it has to be. Yeah, that's it. So it's oh, where's the future? This, there is a normal distribution.
This is not sort of. It's only based on house. So you just need to wait this thing that the man also different. So you did that, so it's not going to be it. It's fine. I'm thinking.
So what did you get for your, if you look up at H of Z score of 0.25, what did you get for your Z score? 0.67, eh? So this Z score here is 0.67, and then this one must be negative 0.67, right? Definitely a negative sign for Z score, right?
It's quartile rate the difference in the X values.
So yes, it's the actual values. Right, the Q1 you should get. So this Q2 here was 7.5. Moments. So Q3, sorry. That is equal to X minus mu.
I never have said anything anyone say. What did they say? You said things that I think. No, oh, yeah, it's all. I'm thinking, but what's the final on the?
Q3 you should get 8.003.
So what's the final answer?
Having 9.
So if you got on Q3 and Q1, you can't assume that Q3 was 8.
No, because remember it's a negative value, so you can use some things.
No, you can't. Look at the diagram. This is 7.5. This is 7.5. This is 8.0. Your X score here is use your diagram as a check. It's 8.003. So to find Q1, you have to use a negative Z score. Okay. So if you use Z sigma plus mu is equal to X, that'll be X3 over here. Okay. Then you're going to get negative, the Z score is negative, so you get negative 0.67, okay, times sigma, which was equal to 0.75, that's mu, which is 7.5, and that's going to do Q1, so you should put Q1 is equal to 6.998. Your interquartile range will be 8.003 minus 6.998, okay, which is equal to what? Actually, not the final answer. Okay, what did that work out to be? Interquartile range.
1.0050 or 1.005.
1.005. Right, did you get that, guys? The interquartile range. Okay, so the key idea is just this. The quartile, the median and your mean, the definition of normal distribution is your mean and your median are the same, right? Okay, so your median, it always goes, they give you the median for a normal distribution, they're giving you the mean. Guys, you've all got this answer. Just check this. Okay. Should put 1.005.
They rounded down. I thought it was 149.7, but then they round down to 147.
Question there.
What if there are 200 people, what percentage is taken less than?
It's late, then you gotta go down.
Okay.
Yes.
There's a bit of an actually.
No.
Like.
Don't go think all the time. Okay,
Hundred times.
that's what happened.
The probability is because it's not. 200
No,
no,
it's not so much.
Everyone okay with this question? Right, I'll silent assume in this case. That's what I'm saying. Right.
Yes.
Well, for A, we had the answer, right? The answer for A.
So whenever
And that's one second thing. So, probability X is less than 8 was equal to, okay, the answer for A was 0.7486, right? Okay, so if your probability of something is 20% and there are 50 of you, we 50 times 20% would be the number of people. Would be the probability times the number of things in the whole sample, right? Okay, so the probability of X if people sleep less than 8 hours is 0.7486. In question C, we've got a survey of 200 adults. So what's the number of people? Okay, so the number of people that get less than 200, that get less than 8 hours sleep. Okay, so the number less than 8 hours will simply be equal to 200 people, the probability times your percentage, which is 0.7486. You agree? Okay, and that should give you 149.72. Okay, so less than 8 hours sleep a night. 0.7486. Why do they round down? Okay, so 150. They won't. Those 150 is the 150th person. Okay, okay, the 150th person would have more than 8 hours sleep last week, right? So you've got to go down. Okay, so it'll be equal to 149 people. Does that make sense? Okay. One more question. 2.2 and then we go.
Oh, boundaries.
Those are your boundaries. So where does the sample group live?
In the middle.
In the middle.
How do you know that's a boundary?
Because it says a confidence interval. So the lower boundary is 5.99, upper boundary is 8.01. Okay, that confidence interval was based on a survey. Okay, in the survey, the actual mean of the sample will be in the middle of the confidence interval. You with me? You guys are doing well. You're gonna be fine. Okay, there you are.
On question 2, I'm sorry.
Yeah, but we're talking about it. So, okay, so, and you don't have adrenaline. In the exam, you don't have adrenaline. Okay, what you do, it makes a huge difference. Okay, wow, that is a hell of a name, right? Okay, yeah, she did. Come good to a nice sheet. Did a study on the corner. Each mask has been equally exposed to virus script and the function was found. So, okay, so your confidence interval, so for A, in a normal distribution, I mean, in for confidence interval questions, you get your lower boundary of mu and your upper boundary of mu based on your sample mean. Okay, usually it's the other way around. You get given the sample mean and then you determine your confidence interval. Okay, but the lower boundary is here, in this case, is 5.99, and the upper boundary is 8.01, right? So the sample mean lives in the middle of that. So you just add them up and divide it by 2. And what did you get? Good, 7. Okay. Right, so now you know X bar. So now you can pick a boundary. Okay. So if we work, what do you want to work with? Upper boundary, lower boundary? Upper. Okay. So if I work with the upper boundary, which has a score of 8,01. Okay. And I'm going to use the confidence interval formula. Where's the confidence? It's, sorry.
Z equals
Using the one at the
X
bottom left, taking from the bottom on the left. So you're using mu is if I use the upper boundary, it's x bar plus z sigma over root n, right?
X bar minus mu over sigma over root n.
That's for hypothesis testing. Okay. Right, so if I look at the upper boundary, you could use a lower boundary. So I'm working with the upper boundary over here. Okay. So I'm working with mu of the upper boundary. Okay. And I've got to go figure out the Z score. Once I've got the Z score, I can get the area H of Z score, right? Okay. So the upper boundary of the U is 8,01 is equal to X bar, which was 7, plus Z standard deviation is 3,5 over root N, which is root 58. And you've got to go solve for Z. Let me know. Okay. So if you manipulate that, you should get Z is equal to 2,04. Did you get? Did you get Z score of 2,04? Okay. So this Z score here is 2,04. Okay. So now to find the confidence interval, you need to go find the area, right? Okay. So the area, so we're looking for H of 2,04. So look at the Z score of 2,04. What's the area going to be? 0,4793. Yeah. Okay. So your confidence interval is going to be equal to that times 2, do you agree? Because this area here is 0,4793. So that area will also be 0,4793 because of symmetry. No, the symmetry they're going to be the same, right? Yeah, confidence intervals are always symmetrical, right? Okay. So it's 0, you just round off in this case. 0,4793 times 2 gives you 0,9586, which is approximately 96% confidence. You just round off. I do like number of people at least at most that you worry about that up and down things. All right, well done, guys. Yeah. The area that we serve. Yeah. No, you equal X minus equal to A minus B. All right, thanks, guys. Well done. Okay, as I say, you're going to be fine. Oh, well done, Rosie.
You know what that means?
What does that mean?
You wrote it so badly.
Control H. All right, thanks, guys.
Well, we're gonna carry on to 2.5 tomorrow.
Yeah.